So as I mentioned, we need to find the distance between the top and bottom nodes, the animated transforms, and then the distance between those top and bottom rest transforms. Now, you'll notice I grabbed the local X form, which if you go and look at the graph, the local X form is different than the X form. X form is the position of that joint in world space. And the local X form is similar, although once scaling of the parent nodes goes into effect, it has some different calculations. So you actually want the local X form when in this particular case, because we are potentially dealing with scale orientation that we need to maintain, okay? But the main thing that we need to do now is we've got these matrix 4 variables coming in, and we don't need the distance between the matrix. We actually need the distance between the transforms, the actual vectors of the T, basically this T, and we don't care about the rotation and scale right now, okay? So what we're going to do in order to just get at the translation part of the matrix, I'm going to declare a local xform T variable. I'm going to set that equal to apex.transform, and here's a new function called explode. And basically this is just saying, hey, take this top local X form, this matrix 4, and blow it up into all of its constituent parts, which is the translation, the rotation, and the scale vectors. And it turns out that, you know, it returns a tuple. The very first vector of that tuple that it returns is the translation, which is what we're going to assign to this variable, okay? And that's what we want. Now, we want that for all of the other ones. So that was the top local X transform. We want a bottom local X form T equals apex.transform.explode. We want that to be the bottom local X form, okay? And then we need the rest local transforms broken out as well. So let's do the top rest local, we want the top rest local X form T, equals apex.transform.explode. And we want that to be the top rest local. And then we got the bottom rest local T, okay? Apex.transform.explode. And this is the bottom rest local, okay? So now we've got the vectors, all right? And at this point then, I need to get the animated distance. So the anim distance equals, and I'm going to use a distance function, and this is a top level Apex script function. And this is going to be where we take the top local X form T that we just defined, and we want to find that basically this is subtracting the bottom local X form T, okay? That's our animation distance. And then our rest distance is going to be the distance of our top rest local X form T and our bottom rest local X form, and our bottom rest local T, okay? Great. So now we've got those, and these are floats, okay? We've got basically the difference between, or we've got the animation distance and our rest distance, okay? Now what we need to do is we need to find the difference between those. So we just simply just subtract the two. So we say anim distance minus rest distance, all right? And at this point, you know, we've got basically the change between our rest and our animation, okay? Now at rest, that's going to be 0. And so what we want to do is when we start talking about our yScale vector, we want that to basically at rest, we're going to add 1 to our diff, such that if we didn't do that, you'd see nothing at rest because your scale value would be 0. And our scale value needs to be 1 at rest. And then at this point, we're going to create a scale variable here, which is going to be the diff, our diff, divided by the rest distance, because we want that scale ratio that we're going to apply to the X and Y. And more importantly, we're going to actually give it this is the actual scale where we're going to take our yScale, let's see, yScale, and we're going to subtract, and we're going to give this just a multiplier in order to exaggerate this. And I'll show you what this looks like here in a second. Okay. And then we're going to take this and we're going to make sure that it can never, the value here can never be below 0 or greater than another one, greater than a value that we can declare. And that's where we can say, hey, we're going to create a clamp value. And this is where we're going to use a clamp float of API. And this is another top level API in Apex script. And we're going to clamp our scale number. And we're going to clamp that to no lower than 0.2 and no higher than 8.0, let's say. Okay. All right. So now we're going to assign this to a new vector, and that's going to be our deformScale vector. And you can do that simply by just doing take our clamp for the X, our yScale for the Y, and then our clamp value for the Z. Okay. And we're going to return that here. Deform, scale. Okay. And you'll notice here, we've got the deformScale, and you'll see that it's green, and that indicates that it's a vector 3. Last thing we need to do here is we need to connect that to our deformNode. Okay. So we actually need to say, all right, squash node dot deformScale out dot connect to our deformNode dot sin. Okay. That's the scale in on our object. So now at this point, if I typed in everything right and my logic's correct, if I come over here and drag, we get the squash and stretch. And everything's working as it should. And see, it doesn't allow me to go any lower than 0.2, right? And it doesn't allow it to get bigger than 8 times the size of the XZ scale.